guys, this lesson is about relative frequency and experimental probability.
You're gonna love this game. Flip the coin.
Okay.
Heads. I win. Flip again. Heads. I win again. Flip again. Oh, tails. You lose.
Hey, wait a minute.
Isn't this a great game?
In a probability experiment, you carry out or observe an action repeatedly. Each observation of the action is a trial. Keep track of the total number of trials and the frequency of each possible outcome. You can use a ratio to find the relative frequency of a given event in the sample space of the experiment. So the relative frequency of an event is found by taking the number of times the event occurs divided by the total number of trials. Like the number of times that you flip a coin and get tails divided by the total number of times that you flipped a coin. Now, there is a tool that you can use in Digits to help you run trials. Like rather than actually have a coin sitting there on your desk or really having number cube, you can do a digital version on Digits.
In this video, you will learn about the probability tool. You can use this tool to perform experiments to determine probabilities of single and compound events. The two drop-down menus in the main workspace allow you to select the device you want to use. The choices include a coin, spinner, bag of marbles, deck of cards, and number cube. Selecting the coin option will open a window where you can specify the probability of getting heads on a toss and the probability of getting tails on a toss. The initial settings specify that both outcomes are equally weighted. That is, the probability of tossing heads is equal to the probability of tossing tails. To change the probability of an outcome, click and drag on the arrow on its slider. The tool automatically adjusts the probability of the other outcome to ensure that the sum of the probabilities is always 1. When you are done setting the probabilities, click the OK button to keep the changes, or cancel to keep the original probabilities. To change the probabilities of the outcomes, you can click on the Properties button next to the drop-down menu. The number of trials in the experiment is initially set at 10. You can change the number of trials by clicking in the Trials field and specifying from 1 trial to 500 trials. If you decide that you don't want to change the current number of trials, click the X to close the keypad and keep the previous number. If you do want to change the value, click the Enter button. Then click the Run button to run the specified number of trials in the experiment. You can pause the experiment at any time by clicking the Pause button. The trial indicator shows how many trials have been performed, and the outcome of each trial is shown below the coin. Click the Run button again to continue with the experiment. When each trial finishes, the trial indicator and outcomes update accordingly. The buttons at the bottom of the screen show different aspects of the experiment. Clicking the Random Events Generator button displays the current view of the experiment, the device, and the total number of trials. Clicking the Event Table button will switch the view to a table that lists each trial in the left column, along with its outcome in the right column. The device used in the experiment is listed above the table. As each trial is completed, the table updates to add a new row recording the outcome. Clicking the Experiment Table button will switch the view to a table that lists each possible outcome of a trial. You can use the checkboxes in the column headers to show or hide the values in each column. The Count column shows the number of times that each outcome has occurred so far. The Experimental Probability column shows the experimental probability of each outcome based on the Count column. The expected count column shows the number of times that each outcome is expected to occur. The theoretical probability column displays the theoretical probability of each outcome.
We'll be talking more about experimental and theoretical probability, but I already talked to you guys a little bit about this. In the experiment, so far we have 5 heads and 8 tails. So the chance of getting heads, according to our experiment, is 5 out of, well, 12 total. Or sorry, 14 total. And that makes a 38% chance for heads and a 62% chance for tails. Well, we know that really with a coin, the chance is 50-50. So we can see the theoretical probability here. So we're expecting to have 7 heads and 7 tails, but so far we have 5 heads and 8 tails. This is what's happening in the experiment, and this is what should happen according to the way the coin is designed.
Notice that as the experiment continues to run, the values in the count column and experimental probability column update to include the most recent trial results. Clicking the tree diagram button will switch the view to a tree diagram of the possible outcomes. Clicking on a node in the tree diagram will display its theoretical probability. To run the remaining trials all at once, click the Skip to End button. The event table and experiment table now show the final results of the experiment. Click the Reset Total button to run a new experiment with the same device.
Spin the spinner 40 times. Keep track of the frequency of each possible outcome, 1, 2, 3, or 4. Find the relative frequency of each event as a fraction and as a decimal. So we're going to do each event and keep track of the relative frequency each time. You can go to your digits. If you'll pause the video, go to your digits. If you log in, then here in the corner, right top corner, there's this tools button. Click on that, click on probability, and you can open this same tool so that you can even run your own trials. Okay, but I'll run one here. So we want to run the spinner. We already have spinner selected. We want to run it 40 times. And we want to know about the event of spinning a 2. So we'll run this, and I'm just going to fast forward it. We can check out maybe our event table to get some results easily. Or our experiment table, I like better. So here we can see how many times we got each number in our 40 trials. And to get our relative frequency, we would want to know how many times this event occurred divided by the total number of times that we tried the event. So for event 1, we wanted to spin a 2. So that happened 11 times out of 40. Now if you run your own trial by going to the math tools and digits, you will get different results than me because I just ran a trial here. So 11 divided by 40, we can write that as a fraction and as a decimal. So far we have a fraction, we can't reduce it. To get a decimal, we'll divide, and this is 0.275. Alright, and then we can do event 2. So the event is to spin an odd number, so that would be 1 and 3. So that happened 15 times out of 40. We can reduce our fraction. And we can also write this as a decimal. This is considered our relative frequency because we are counting the frequency of the number of times that the event occurs and dividing that by the total number of trials. Okay, here in this example, we are already given a table of outcomes. And it says that the spinner was spun 40 times. What's the relative frequency of the event spin a number less than 4? I would pause the video, do it yourself, and play the video to make sure you did it correctly. Okay, so we want to get less than 4, so that means a 1, 2, or 3. That would be the frequency of how often that happened would be 26 out of 40 trials. It doesn't tell us if it wants a fraction, decimal, or percent, but we can definitely list it in various ways. All right. Here we see that a table shows outcomes for spinning a spinner 40 times. It says, suppose the class spins the spinner 40 more times. Do you expect the relative frequency of the event spin a 2 to change or to remain the same? Well, the relative frequency is kind of like the percent of time that you get a 2. We kind of talked about this already, but it seems as though whenever we are really spinning this spinner, we should get a 2, or we have 2 chances to get a 2 out of these 8 total possibilities. So that would be like 1/4 of our spinner, and you can see that if you cut it like a pie. But 1/4 of our spinner is a 2, so we should get a 2 1/4 of the time. Well, so far we've done this 40 trials and we've gotten a 2 12 times. 1/4 of 40 would be 10 times. So as we spin the spinner more and more times, we probably should get closer to really being truly 1/4 of the time. So I would expect it to change. And the more times you spin the spinner, we would expect it to be closer and closer to 1/4. So if we spin it 400 times, then we would expect to get a 2 100 times. The relative frequency would be 100 times of getting a 2 out of 400, or the 1/4 like we talked about. You would expect to really get the 2 1/4 of the time, or like 25% of the time. And so the more times you spin the spinner, the closer we should get to that relative probability, or the relative frequency. Whoops, whoops, whoops. Okay, sorry I got a pop-up, but we're good to go again. For the key concept here today, we've been talking about relative frequency. So finding kind of like the percent of times that you get what you're looking for. You can use relative frequencies to estimate the probability of an event. A probability found this way is called an experimental probability, because you're finding the chances by running an experiment and seeing how many times it happens. The greater number of trials, the closer the experimental probability will be to the actual probability of the event. I talked about this a little bit the other day, but this is called the law of large numbers. So if the more times that we do the trial, it really should go to the true probability. Like if you're flipping a coin, the chance of getting heads is obviously 50%. There's no reason why one is more than the other. And so the more times you run the experiment, the closer that probability, or that experimental probability, is going to get close to what it truly should be of 50-50. So the probability, experimental wise, is the number of times something occurs divided by the total number of trials.